All right, let's take a look at this one, number 11 in section 3.8. We're going to basically calculate dy over dx, I would say implicitly or using implicit differentiation. So that's what we want to do here. We do not want to, we cannot solve for y in this equation here. It would be impossible to do so. So we have to use implicit differentiation to find dy over dx. We're going to call that y prime for notational purposes or for ease of notation down here. And so to find the derivative, implicitly, we take the derivative with respect to x of both sides. And we're going to assume, again, y is a function of x. Y is a function of x. So what do we have here? Well, we have e raised to the 2xy power. Well, that's a composition of functions. The inner function is 2xy. The outer function is e to the u. That's the outer function, e to the u. So we have to use the chain rule. So remember how the chain rule works. It's the derivative of the outer function. What's the derivative of e to the u? Just e to the u, where u is 2xy. So I get e to the u, e to the 2xy, times the derivative of the inner function. So the derivative with respect to x of 2xy, what do I have to use there? Remember, y is a function of x. So I have 2x times y. That's a product rule, right? Both of these are functions of x. So I take the derivative of 2x, which is 2 times y, plus 2x times the derivative of y with respect to x. That's the dy over dx, which we're going to write as y prime. So make sure you use the product rule there, right? So here's chain rule, e to the u times the derivative of the inner function, and then in that inner function derivative, we're using product rule. Okay. On this side, notice I have a composition of functions too. Outer function sine, inner function y to the fifth. Chain rule again. Derivative of the outer function sine is cosine. Evaluate the inner function y to the fifth times the derivative with respect to x of y to the fifth. All right, that's the inner function derivative. Well, y to the fifth, notice it's with respect to x. So it's just not 5y to the fourth. Y is a function of x. So this is a chain rule again. Inner function is y, outer function is y to the fifth. Derivative of the outer function, power rule, bring the 5 down, y to the fourth, times the derivative of the inner function, and the inner function being y, its derivative is just, again, y prime. Okay, so that's a lot of stuff going on there. Let's just clean this up. I'm going to distribute this e to the 2x through, because my goal now is to solve for y prime. So I have to sort of separate these two terms by distributing that through. Excuse me. And so I get 2y times e to the 2xy, and then I get 2x e to the 2xy times the y prime. Over here, I'll just bring the y prime to the back. I've got 5y to the fourth. All right, bring that in front of the cosine of y to the fifth. So I just need to get all my y prime terms together. And this one doesn't have y prime. I want that on the other side of the equation. So all I'm going to do is just subtract this from both sides, which I've done here. Then I have that common factor of y prime. I want to factor that out of these two, right? And that leaves me this stuff here. And then solve for y prime. So y prime times all this stuff equals this. I'm going to divide this by everything in the parentheses here. So again, we get this crazy looking expression we're used to getting with implicit differentiation. It's a derivative is a function of x and y. And you got to be careful, you know, a lot going on here. Be careful when you're entering it in to achieve that you do so correctly. Okay. All right. Hope this is helpful on this one.